All right, so we are going to continue talking about different kinds of proofs. This time we are going to talk about segment proofs and angle proofs. Now, much like algebraic proofs, triangle proofs, this video is going to be pretty quick because a lot of it is just using, you'll notice a few pages of these notes are just different postulates. Many of them which you already know. To prove whatever it's asking us to prove. So I'm not going to read through them with you. You can do that yourself. So I'm just going to go through a couple of these different types. I'm going to go over 2 of them, and then I'm going to have you guys try a bunch on your own. And then we will talk about it. So I am going to go, I believe, is the 3rd page of your notes. This right here. Okay. So it is giving me the following. AC is equal to AB. Now something that we kind of need to retrain our brains to do is to recognize, and I'll show you why this is important in some of them. And I'm not going to be too picky about this, but if you see stuff in the book or in other places, it's a little pickier. When I have something like this, and it just has an equal sign, that means it is talking about the measure of that line segment. So they are talking about the measure of AC is equal to the measure of AB. The measure of AB is equal to BX, and that type of thing. If I'm actually talking about my line segment, it's going to look like that. And if it says congruent to, congruency can only be technically between line segments. It has nothing to do with numbers or measures. Whereas if I just write it like this, I'm talking about the measure of a segment. So, okay, and I'll show you why that's important in a different one. So let's take a look at what they gave us. All of these, it gave us all of our statements, and we just have to provide the reasons. So that's a little bit easier for us. And what we're going to do is, again, we're just using all of those different postulates on those first couple pages to determine our reasons for being able to say these things are true. The first one, AC equals AB and AB equals BX, that has not changed from our triangle proofs. That's just a given. They told me that, I'm going to use that. Okay. The next thing that I'm going to say, though, it says AC equals BX. Well, why do I actually know that? We have talked about this a little bit. It is called the transitive property, and it is on one of those first pages of notes. It's on the very first page at the bottom, the transitive property of congruence. That basically says if I've got AC equal to AB and AB is equal to BX, I can get rid of that AB in the middle and say, okay, those other two things are equal to each other as well. So I'm going to say AC equals BX, reason being transitive property. Okay. CY equals XD. That's another given. So they split it up a little bit. It's a little goofy, but we're going to go with it. So that's given. And now they're saying AC plus CY equals BX plus XD. Well, what's that all about? You might say that you're basically just taking this and adding it to the other one. And that's exactly what they're doing. They're just taking this and having that be one side of your equation, and the other side is adding this. My reason is just addition, which is kind of similar to what was going on in those algebraic proofs that you looked at last time. You're just naming what you're doing. You're adding those things together, so I can say that because of addition. The next thing that I've got is a new postulate that would be on one of those first couple pages. They're saying AC plus CY equals AY. So let me label that on my picture. This is AC. And this is CY. and they said together they make AY. That seems to make sense, but I need to be able to put a name to that. What is that I'm doing? Why can I say that? And what that is it's segment addition. There's on the front, one of those front pages is a segment addition postulate that lets us say that that is the case. So if I know that these two things are equal to each other, and each of them are equal to those two things over here, I can say that those are each equal to each other as well. The reason I can do that is by substitution. And that gets me my proof. They wanted me to prove that AY was equal to BD, well, I just did, by substitution. So I want you guys to try the next two of those. They're both line segment ones. I'm going to get you started on this one, because this one is what I was talking about that distinguishing between this notation and this notation. The first thing they gave me in this proof is just my given. They said that AB is congruent to CD. That's given. But then they basically say the same thing in the second one. AB equals CD. They're talking about measures there. My reasoning for that is definition of congruence. I do not believe that that is on that front page, but all that is saying is that if I have two line segments that I know are congruent, I know their measures are equal to each other, which is what that is saying, what that notation is saying. So that's, I got you started on that. Go ahead and see if you can finish that and this one. So I'll write my little note here. You try that. And you try that. And then let's move on. I don't want to talk about that right now. I want to talk about this one, because this is going to help me show you how to do angle proofs. They are very similar to segment proofs. We're still using a bunch of those, all of those postulates that we've got on the front page to help us reach our final proof. So let's take a look at this. So they give me in the figure NYR and RYA form a linear pair. I think this is a word that some of us forgot because we saw it, I believe, in the last couple classes and everybody was a little confused about what that was. Remember linear pair, so if I'm looking at NYR and RYA, they are a linear pair. It means together they make a line, or another way that we have described those is they are supplementary. So we've got those as a linear pair, and then AXY and AXZ are a linear pair, and RYA and AXZ are congruent. Okay, prove that NYR and AXY are congruent as well. So let me kind of sketch this out. So AXY is right here. That's AXY. And AXZ, it's right there. So they are telling me that these right here are a linear pair, and these right here are a linear pair. Okay, I'm going to get rid of those so I don't get confused. And they told me that RYA is congruent to AXZ. Okay. Easy enough. So now they want me to prove that NYR and AXY are also congruent to each other. So let me see what they gave me here. They told me that right here, this is a given. NYR and RYA and AXY and AXZ form linear pairs. They gave that to me, so I'm going to write given. So the next thing they tell me, they say NYR and RYA are supplementary, and AXY and AXZ are supplementary. It's something that we've talked about before, but there is one of your theorems on the front is called the supplement theorem. And basically what it says is that if I have got two angles that form a linear pair, then they're supplementary angles. That's all the theorem says, and that's something we've already talked about. The next thing they gave me, RYA is congruent to AXZ. That is one of my givens. It's a little bit wordy, but they did give it to me. So that's a given. And then the last thing they have there is angle NYR and AXY are congruent to each other. That is also part of our theorems that we have. Theorem being congruent supplements theorem, which basically says if I've got angles that are supplements to the same angle or to congruent angles, then they are also congruent. So that is how you don't have to write that whole thing. Sometimes you are going to see that whole thing written, but I'm cool with you just saying congruent supplements. And also, just like with our triangle proof, these don't have to be anything pretty or anything specific. You can write that whole thing there, that I know that those two are congruent because they're supplementary to congruent angles. And that's okay. So, you take a look at these two. And see where you can get. And we'll talk about it.